Hello, everybody, and thank you for joining this webinar. It's already 3 p.m., so I guess we can start. My name is Antonina Hryszczuk. I'm a data scientist at Mayato. Mayato is a consulting company. We are based in Germany, and we are a partner of Knime. Today, I will speak about customer segmentation, but before we start, I would like to highlight that that you can post your questions in the Q&A section. You can also upvote for your favorite questions so that I can see that you are interested in answer. We will have a bit of time at the end of the webinar, so I can answer the questions. And if I don't have enough time for all of them, you will get a report via email a few days later. Also, the session is recorded and it will be available on YouTube. So you will also get a link in an email a few days later if you want to look at it again in a few days. The Q&A section can be found in the bottom part of your Zoom window. You can find it the second button. And I would actually like to answer one of your questions before it is asked. Unfortunately, I can't provide the data or the Knime workflows because it is a data security policy of our client company. But if you have any client unspecific questions, or for example, to our methodology or to our approach, then you can always contact me or Mayato and we will try to help you. So what is it going to be all about? We will speak about customer segmentation for a German energy provider with Knime. I will first introduce to you Mayato and then our client company. I will tell you what was their problem and what did they try to solve it. Then we will take a short overview of the input data, and I will provide a small live demo in Knime so you can see the workflows and how they work. And at the end, we'll take a look at the results and lessons learned and proceed to our Q&A session. What is actually Mayato? Mayato is a German consulting company. We are providing solutions in big data, data analytics, business intelligence, and data science. Speaking about data analytics, we provide solutions in very different fields of it. For example, in customer analytics, in industry analytics, in image recognition, natural language processing, and so on. In the field of customer analytics, we are optimizing marketing campaigns. We are doing cross and upselling, doing media analytics, reactivating so-called sleeping customers, and also helping to identify the churners. That means customers who are going to quit their contract and leave the company. So customer segmentation is apparently also an example of customer analytics. How did this use case found us, or how did we find this use case? We were contacted by a big German energy provider. It supplies electricity and gas for private and corporate customers across the whole country. Their idea was to get a notion of who are actually their customers. Because for years, they put their focus on products. They tried to invent new electricity tariffs and just sell them to all customers, or at least try to offer them so the customers could buy them. The big vision for the future was to move this focus from products to customers and to offer an individual service experience for every customer. What does it mean? The customers are extremely different There is no perfect service for the whole customer base, so it should be always tailor-made to make everyone happy, if you can try to do it. I summarized the customer differences into 4 dimensions. The first one is profitability and reliability, which is probably the most important one for many businesses. In our case, it means that some customers pay their invoices, their electricity bills, some not. Some customers are too late with their payments. Some customers consume a lot of power, some customers not. So of course, the company might be more interested in keeping the profitable and the reliable customers. The next dimension is anxiousness. There are customers who are very afraid to make a mistake. They always want to contact the company to be sure that they are doing everything right, and they need a lot of information on their contract, on their tariff, on their bill, on everything about this. And you can, of course, only make them happy if you provide this information to them. There are also customers who want to hear really a lot from their energy provider. So they are extremely talkative and want to interact a lot with their energy provider. There are other customers who think that the best energy provider is the one who doesn't bother them. This was the third dimension, willingness to interact. And the last dimension is media affinity. It's supposed that older people prefer the personal contact, so they like to go to the customer support center, and they value this possibility of personal consultation. Whereas younger customers value their time and prefer online services. How can you assign this dimension of this characteristics to different customers? The first approach is to develop so-called personas. This is what the company did before they contacted us. Personas are fictional characters for different user types, which are developed only on the basis of intuition. That means you don't need any data to develop them. You can develop personas if you just ask a lot of people or a lot of employees of the company who are at so-called touch points, so they have a lot of contact with the customers. And if you ask them, what are actually the typical user types which are you dealing with every day? This is what the company did, and they developed 5 personas, the anxious one, the problematic one, the lazy one, the advanced one, and the active one. But it's also very important to know that these personas were developed with a focus on service. So if you are interested in a difficult, in another focus, then the personas would look completely different, probably not, but it's important to keep that in mind. Our idea was to compare this business-based approach to a data-based approach, so that means to clustering. The first and the most important question was, of course, can we find these persona in our data? Are there any redundant or new personas? And how can we actually link the persona characteristics to our data, just to the numbers? And what is also quite important for many businesses is the profitability. That means what are actually the cluster sizes? Is it really profitable to handle them in a different way, to provide them a different service? Or are some clusters maybe so small that it just doesn't make any sense? And for us as data scientists, it was also very interesting to compare if the cluster sizes that we calculate are different from the estimations of the customer support team. Here on this slide, on the right side, you can see an example of such a persona. As I said, there are 5 of them. I will show an example of one, but 4 others have the same structure. So may I introduce you to Jacob. Jacob is 35. He lives in Berlin-Marzahn. Berlin-Marzahn is a rather poor part of Eastern Berlin. Not the best one in Berlin. Jacob is married, he has 3 children, and he works as a cashier, so he doesn't earn a lot of money. He loves football and beer, and he has a basic electricity tariff. Jacob pays mostly in cash at the ATM in the customer center, so he goes to the customer center like every month. And he mostly interacts with the energy provider at the customer center, often because of dinings, because he often pays too late. What is important for him is a secure income for a better future for his children. So the question is now, how can we link these characteristics, which are quite different in their structure, to our data? Some of them are quite easy. For example, if you know the birth date of a person, it's easy to calculate the age. And also, you normally have the data on contracts and payments, and you can calculate the data on contact channels if you know how often the person contacted the company via phone, via email, or personally in the customer support center. Some other characteristics are much more difficult. For example, you might have the address, while it can be anonymized partly, at least the house number, but it can be very cumbersome to know for every village and for every city in Germany, is it a good district or is it a bad district? It's possible, but it's it takes some time. And the same applies, for example, for the family size and marital status. If you're happy, you have this data. If not, then you can only estimate it if you have the power consumption numbers, because a larger family would probably consume more power than a small single person family. But it's still a rough estimate, so it's not really precise. And of course, there are characteristics which are generally quite impossible or extremely difficult to calculate. For example, the profession or the hobbies or the values, if you don't have them. As for values, it's actually text, so you need language processing techniques to analyze it. It's possible, but it might be a bit beyond the scope of your project budget. Our input data can be a bit derived from what I said before. We have these 4 dimensions and how we want to estimate our customers. And so we also develop our variables. To estimate the profitability and reliability, we need the data on consumption, payments, and data on dinings. And dinings or reminders are especially important for estimating the reliability. To estimate the anxiousness, you need the overall contact counts and also contact counts after certain events. You can imagine that some customers, especially after they get an invoice or a dining, they get extremely nervous and want to contact the company. So it might be a sign for an anxious customer. To estimate the willingness to interact, you also need the contact counts, maybe some other variables. And to estimate the media affinity, you need the contact frequencies per channel and the data on online activities if you have them. And of course, it's always very helpful to have the demographic data because they often help a bit or a lot. And it's in our case, it's also good to have the data on the contracts. For example, the start date of the contract or some circumstances of this contract. So you see that it's cross-sectional data with a focus on service. And now I invite you to join the live session in Knime. So this is my Knime workspace. I divided the work for this project into 3 workflows, and I cleaned them a bit for this webinar. For example, I anonymized them. The first workflow is about preprocessing data. The second one is about normalization. The third one is the clustering itself. Before I started with data cleaning, I excluded some non-private customers and housing associations. Why? Because they have completely different patterns from the private customers. You can't compare the date of starting a housing association with the birthday of a person. And also, for example, the power consumption of a housing association or of a company can't be compared with the power consumption of a single family. In the next step, I did some data wrangling and data cleaning. This is my favorite part, standardizing the date format. It's always a bit funny because, for example, in this case, we found some customers who were born in the 12th century. Of course, it was just an error. And we also had some customers who were younger than 18 years old, partly even like several months old, so babies. It was also an error in the data which had to be cleaned or replaced if we could reconstruct the real values. And here I also calculated the date differences, for example, the age and the duration of the contract. In the next step, I did some feature engineering. It's important to note that clustering is a distance-based method. I'm using k-means here. K-means is distance-based, so it's very important to take care of outliers and untypical numerical values. I did it in several ways. The first one here was binning of continuous variables. I did it, for example, for the corrections, which are paid once in a year, for monthly rates, for consumption, the number of debits, and so on. And at every step, it was also important to search for mistakes because it was quite a lot of them. Some of them are mistakes, some of them seem to be mistakes, but are no mistakes. For example, here, the first case, the consumption of power and gas is unknown, but the overall consumption is 0. So it's not really consistent. And we also, that was an error, but we also had customers with negative consumption. It might seem as an error, but it was a real case, which could be explained by the business logic of the client company. So I also did some bin of tannings and of the postcode and the number of contracts, and the clean data were the input for the second workflow, the normalization. Here I also started with the feature engineering block. I calculated the number of favorite contact channels and the personal contact affinity, and also the first contact channel affinity. A channel is, for example, a personal contact in the customer support center, or a contact per mail, per phone, or even a letter. And it's quite interesting to see that different customers tend to prefer different contact channels. In the next step, I did some normalization. I did it in 2 ways, besides being the continuous variables. For some variables, I applied the logarithmization, and for some variables, I did the min-max normalization. The goal was always to approximate the standard normal distribution. And I also additionally did some outlier treatment. You can see here that I replace the outliers by the closest permitted value. Normally, you will find the interquartile range multiplier of 1.5, but I didn't want to be so restrictive, so I put here 2.5. And the last part was creation and normalization of dummy variables. So after this part, all of our variables were in a numerical form as you need for the clustering. And the last part was, of course, to choose the input data, the final input data, to get rid of all the auxiliary variables. The final part, our final step was the clustering itself. I applied the elbow method to identify the optimal number of clusters. You can find this part of the workflow, the green one, on the Knime hub if you search for elbow method. I used or I tried out 2 to 10 clusters, and the idea of the elbow method is to compare the sum of squared errors between clusters for different number of clusters. You can see it here at the plot. You have 1 to 10 cluster possibilities. Here at this plot, it looks like 2 clusters are the best option because the drop here is the biggest one, but 2 clusters were were not enough for our client company. So I investigated 5, 6, and 7 clusters because the drop here, as you see, it's still quite substantial. And 7 clusters produced the stablest and the most intuitive results. So it was the number that I picked for the final iteration. And the result was the list of all clients added to the cluster assignment. Back to our presentation. What were our results? On the right side, you can see our Jacob. And on the left side, you can see the characteristics of the cluster which corresponds to Jacob. The orange line are the average values for this cluster, and the blue line are the average values for the total data. The first question is, of course, which cluster characteristics could be confirmed? Is it really Jacob? And yes, it is really him. You can see, for example, that he is quite young in our persona description. 35 is very low for an energy provider because you can't have any babies in the contract. And you can also see here that the cluster average is definitely below the total average. You can also see that Jacob has a lot of center visits, a lot of cash payments, and a lot of dunnings, and it completely goes along with our persona description here. Jacob pays in cash at the ATM and visits the customer center mostly because of dunnings. But not everything can be confirmed by the data. For example, it was supposed that Jacob is married and has 3 children. But as you can see, his consumption is rather average or even below average. So it doesn't look as if he had a big family. Which consequences could it bring for the customer service? Of course, the first and the most evident consequence is that Jacob is not a very profitable customer because he pays quite low mean rates. And unfortunately, he's also not the most reliable one because he has a lot of dunnings, so he produces a lot of additional costs for the company. So probably if Jacob decides to leave the company should not be very sad. But if the company wants to keep him, it's best to reduce the mean monthly rate or the monthly rate because this customer is extremely price sensitive. And such consequences, we developed such consequences for every cluster. So the list with the cluster assignments and the list with our suggestions suggestions for the customer service was a result of our project. Thank you for your attention. And now we have maybe 5 minutes for the Q&A session. I will take a look at your questions. Thank you for the interesting use case. How long it took to go from raw data to results? Actually, the most difficult part was the data engineering part, or it was maybe not the most difficult part, but it was the longest one, because energy providing companies are normally not so far in the process of applying data science or big data. So it was quite cumbersome to get all the important data and to explain all that we needed. In total, it was from starting the use case, from developing the use case to presenting until presenting the results, it was half a year. But if you already have the data, then it can be done much quicker. Do you have the link of the model also? No, if you are asking about the workflow, unfortunately I can't provide it, but the model itself is a normal k-means algorithm. The difficult part is the preprocessing part, because the data are quite dirty. What did the other personas look like? How did they differ? Oh, they were extremely different. Jacob is a problematic type, so that's why I picked him. There were also one persona was the cozy, the lazy customer who was very happy to, if he had no contact with the company at all, he paid quite high monthly rates. So it was a profitable customer who just didn't want to get in contact. Another cluster was, for example, as I said, the anxious one. He needed really a lot of information, so it was good to send longer and more detailed invoices, and also all the details of the contract should be extremely detailed to make him happy. Why did you decide to use k-means? Did you try other methods as well? Yes, we did. We picked k-means at the end because it was the most intuitive algorithm for the client. So as one of the first projects, it was good to make something that that makes sense for the client, but also is scientifically proven. Do I have some personal advice to avoid when developing this project? My personal advice is not from the data science side, but more from the project management side. For developing this project, you have to work a lot with data engineers, or maybe you are developing it yourself, but it's extremely important to have a lot of discussions with them so that they develop exactly the way of data that you need. And also it's a good idea to have a contact with the client all the time, because sometimes the wishes can change. For example, first we developed these 7 clusters, which I told you, but then one cluster was too small, so the client calculated that it's not really profitable to provide a special service for this cluster, and we added this cluster to another one. I don't have so much time, so I guess I will answer just a couple of questions, and the answers of other questions, you will get them per email, as I promised at the beginning. How often did you update your model? Did you notice many consumer classifications changes over time? It's a really, really good question. As I said, first we tried out different numbers of clusters, and then we took 7 as a final number, and we tried different modifications. We first applied it on all the input data we had. Then we also applied it just on the most important variables, which were like responsible for building the classes. And we controlled that the classes are quite stable, because it is really a danger. So we wanted to prevent it. Maybe one last question for today. Were new personas identified from the clustering analysis? Did the process differ significantly versus confirming existing personas in the clusters? A difficult question, because it was a difficult process to link the personas to the clusters. You saw that some characteristics could be proved and some not, and it was sometimes not evident at the first sight which cluster corresponds to which persona. So we compared, so several people compared them so that we can really compare our results and see does it, if this cluster corresponds to this persona or not, because it's really also a bit in the eye of the observer. I think I don't have much time now. As I promised, you will get all the answers. Thank you a lot of them. I will get back to you. Thank you.